Hello everyone, this is Mr. Ahmed Al Qadri, and today we will continue our lesson about heat, and we will start with energy and temperature. Okay, guys, we all know that thermal energy is the energy due to the motion of particles and matters. If we place a thermometer and boiling water registered about 100 degrees Celsius because we know the boiling point of the water is 100 degrees Celsius. So the thermometer measures the temperature of the water. Okay, so the temperature is a measurement of the average kinetic energy of the molecule in a substance. So the temperature is the measurement of the total energy of the molecule in a substance. But the thermal energy is the energy due to the motion of the particles, but the temperature is the measurement of this energy. As heat flows into a substance, the kinetic energy of the molecules in the substance increases as we study last time. So some molecules in a substance may move faster or slower than the other molecules. But overall, the average speed of the molecule rises, so this causes an increase in temperature. Okay, guys, in this experiment, we need a heater, two heater, and two kind of matter. We take as example water and olive oil, and we take a thermometer, two thermometer to see how what is the meaning of measuring of kinetic energy. Right now you can see the olive oil and the waters. We didn't add any thermal energy or any we never heat them till now, so uh, the measurement of temperature or the measurement of energy is still the same in both containers. So right now let's put heat both of them. You can see the flowing of uh, thermal energy. It's faster in olive oil than water. You can see the increases in temperature here and here, okay, between the both of the materials. So this is an example of the measurement of a flowing of thermal energy. Okay, as we learn that temperature is a measurement of the average kinetic energy of the molecule in a substance, so by using a thermometers. So guys, as heat flows into a substance, the kinetic energy of the molecule in that substance increases, as we see and the experiment in the previous experiment. So some molecules in a substance may move faster or slower than other molecules, but overall the average speed of the molecule rises. This causes an increase in temperature. So this increase in energy also cause molecules to move faster apart. So as the molecules in a substance spread out, the substance usually increases in volume. So an increase in volume that is caused by an increase in temperature is called a thermal expansion. Let's do another experiment to explain what the meaning of thermal expansion. Okay guys, let's do a small experiment together. You can see we need a heater and a flask with the water in it, and on the top it closed by a balloon. So if we give heat for the flask, okay, guys, you can see what will happen to the particles of water vapor inside the balloons. You can see right now the volume of balloon is changed when we have increasing of thermal energy of temperature. So you can see right now the volume of the balloon is increases during the time. So because of the increases of the temperature, so you can see the increases of volume. This is what we call thermal expansion. Okay, as you see right now, the volume is still increasing and increasing. You can see the increases of thermal of the volume of the balloons because of the, you can see right here the water start to boil, and the balloons, the particles of the water vapors, it's move faster and faster. Okay, guys, scientists consider the effect of thermal expansions when choosing materials to build houses and other structures. So not all materials respond to changes in temperature in the same way. So some expand more than the other. Not all the materials or the matter can expand in the same way. So some expand more than the others. And let's do another experiment about thermal expansion, but right now we want to see how the particles of the matters is changed. Okay, guys, you can see in this diagram the particles of air, how they are moving in they moving faster than in solid and liquid. So imagine we need, in this experiment also we need a heater for this experiment. If we put more thermal energy, if we you can see the expansion of the uh, molecules of the particles of the air. You can see how it's break apart. So this is another experiment. We can return the lid here right now, and we want to add the particles. You can see we add particles right now, and you can see how they are spread out in all the direction. If I want to put more heat, you can see the expansion of the volume of the particles. They cannot fit in the same way. So when I put heat, so you can see the volume is expand, the particles push this lid and expand in this way. So this is an example of uh, the expansion, the thermal expansion of the particles of matter. Okay, guys, let's talk about the relation between temperature and mass right now. After we study the relation between temperature and volume, and when the temperature increase, so the volume is increase, we have increasing volume. Right now we want to study the relation between temperature and mass. Okay, guys, for example, we take beakers in different sizes. Imagine if we put water inside all the beakers, almost like to the full. Okay, guys, and we put them on a heater. Which one start boils first? Of course, the smallest one, the smallest amount of water, it will start boiling first. So the smallest beakers take less thermal energy from the heater, because as we learn that the thermal energy is the flow of thermal energy from the heater to the beaker, or from one object to another object. So when the heater is transfer the thermal energy to the beaker, and the beakers has the smallest mass of water, so it take the lowest thermal energy. And if we keep them on the same heater, so this the bigger beaker take the larger amount of thermal energy from the heater, because it's need lot of thermal energy to start boils. So a thimble filled with boiling water has a high temperature but little mass. It has less thermal energy than a jug full of water that is warm but not boiling. So overall, a gallon of warm water has more energy than a thimble of boiling water has. So the temperature of the jug is lower, the total amount of energy is much higher. So when this beaker, the small beaker start boils, has more temperature, but the bigger one has more thermal energy than the smaller one. Even the smaller one has more temperature.